So welcome students. We will discuss current electricity JEE 2023 questions. Let us discuss one by one. This is the first question. The equivalent resistance between A and B of the network shown in figure. We find equivalent resistance across A and B. This is a simple balanced Wheatstone bridge. Now we redraw the circuit. Consider 2 points. This is one and this is another point. Let us assume this one is X and this point is considered as Y. So redraw the circuit. Consider A, B, here X and this point is Y. A, X, B, Y. Between A and X there is a resistance 2R. Between A and X there is a resistance 2R. Between A and Y there is a resistance R. A and Y there is a resistance R. Between Y and B there is a resistance 3R. Between X and B, between X and B, resistance 6R. Between X and Y, resistance of 9R. So let us check whether it is balanced Wheatstone bridge or unbalanced Wheatstone bridge. Now circuit is in form of Wheatstone bridge. So whether it is balanced or not, let us check. For balancing condition, bridge to be balanced, condition of a balanced bridge, P by Q is equal to R by S. Let this resistance can be considered as P and this one is Q, this one is R, this one is S. Now check whether it is balanced or not. If this bridge is balanced this condition, then the bridge is said to be balanced Wheatstone bridge. Now check P by Q, that is 2R by 6R is equal to P by Q is equal to R by S, that is R by 3R. That is R by S. R is R, S is 3R. Now cancel, RR cancel, that is this is nothing but 1 by 3. This also 1 by 3. So bridge is balanced. So bridge is balanced. This is a balanced Wheatstone bridge. Now once bridge is balanced, the central part, the central resistance is removed. Then again redraw. The upper part is, that is 2R and this is 6R, and the lower part, this is R, this one is R and this one is 3R. So between A and B, so both this 2R and 6R in series and lower R and 3R also in series. So upper part, between A and B, upper part 2R plus 6R, that is 8R, whereas lower part, that is R plus 3R, 4R. Between A and B, the upper part and lower part is parallel. So 8R and 6R parallel, equivalent resistance across AB is equal to R1 R2, if two resistors are parallel, R1 R2 by 8R into 4R by 8R plus 4R 12R. So R cancel, 4 1 4 3, that is 8R by 3. This is which one? 8R by 3. This fourth option is correct. Next question, see that. So second question, see. In an experiment to find the EMF of a cell using potentiometer, the length of the null point for a cell of EMF 1.5 volt is found to be 60 centimeter. That is, balancing length is 60 centimeter for EMF of 1.5. So we know formula, balance length EMF E is equal to I rho L, where I rho constant, that is equal to E is equal to K into some K into L. So first, for balancing length 60, EMF of a cell 1.5, corresponding balancing length K into L, that is equal to 60 centimeter. This is equation 1. And second one, if this cell is replaced by another cell of EMF E, the length of the null point increases by 40. So another cell is replaced whose EMF is equal to E, and the length is increased by 40. 60 plus 40, 100. So second balancing length is 100. The value of EMF E from equation 1 and 2, 2 divided by 1, do it. So E by 1.5 is equal to K into 100 by 60, that is 100 by 60, that is 6 by, that is 5 by 3. If you simplify that, 5 by 3. So you get EMF is equal to, from this, EMF is equal to 5 by 3 into 1.5. 1.5 you can write 3 by 2. This 300, this 3 cancel, 5 by 2. That is 5 by 2. But what they are given, this value, that is 5 by 2 is equal to, they are given x by 10. 2125, that is, from this x is equal to 25. So x is equal to 25. Next question, see that. Third question. Equivalent resistance between the adjacent corners of a regular n-sided polygon of a uniform wire of a resistance R would be. See, this is a question. So they are given n-sided polygon, like n-sided polygon, one side, like n-sided polygon. N-side, this one is n-sided polygon. Let us consider two adjacent corners. This is let us assume A, and this one B. Each resistance, let us assume each side resistance, each corner resistance smaller, each side resistance smaller, and this one is also smaller. Total resistance of Y, they are given capital R. That is capital R is equal to small r is equal to total resistance by n sides. Small r is equal to each resistance of a side is equal to total resistance R by n number of sides, small r. So all n-sided, all upper sides are in series, that is n minus 1 sides are in series, all are added, that is n minus 1 into small r, and across AB, that is each resistance is R. Between A and B, both are parallel, so equivalent resistance across AB is equal to r1 r2 by r1 minus r1 r2 by r1 plus r2 r1 n minus 1 into r by r1 plus r2, that is you got nr, rr cancel, that is you will get n minus 1 into by n into r. Instead of r you can write that is equal to n minus 1 by n into that is equal to r by n. So final result you will get, that is n minus 1 by n square into capital R. This is n square r by n minus 1. N minus 1, like which one? N minus 1 or by this one. First option is correct.